Well, hi there and welcome. My name is Rebecca Weaver, and we're going to be looking at applications of systems of equations. First up, we're going to do an example of a two-number problem. In order to solve application problems, the number one thing you need to do is understand the problem. That's number one. Step two is always fun, and draw a picture if it applies. I love to do this. Three, write down what you know and assign variables with a description. 4, you're going to construct some equations. Number 5, you'll solve those equations. And step 6, do your answers make sense? Our problem is the sum of two integers is negative 45. The difference of those same two integers is negative 175. What are the two numbers? Step number 1, read the problem. What's an integer? I don't know. An integer is a positive or negative whole number. Okay, so that means no fractions. That's what that means. Step 2, no picture, just a couple of numbers. If x is the first number, then we're going to let y be the second number. So here's my two equations for this one. It says that the sum of the two integers is negative 45. So I'm going to write x plus y is negative 45. It says that the difference of the two integers is negative 175. I'm going to write x minus y is negative 175. I can use the graphing method, the substitution method, or the elimination method to solve this. I stare at these two equations and I say, hey, there's a plus y and a minus y. If I add these two equations, I will get my variable to drop out. One of them anyway, that y. So what I'm going to do is be using the elimination method. So when I do that, I'll add those two x's. I'll get 2x equals negative 220. Cool. Divide both sides by 2. X is a negative 110. That's an answer. Then I'd take one of my two equations. I like x plus y is negative 45. I'm going to substitute in there the negative 110 for x. Add y is negative 145. Just add 110 to both sides. Crunch those numbers. Y is 65. That's the second part. Cool, I have both answers now. Now let's check to see if this makes sense. Is negative 110 plus 65, does that equal negative 45? Yes, it does. What about negative 110 minus 65? Is that negative 175? Yep, it is. Bam! We got it. So let's go and do an interest problem. So we leave our directions up here on our interest problems, and I'll be following those steps. The problem. Ben invested a total of $25,000 into two accounts. Now, one pays 7% annually, and the other pays 9% interest annually. At the end of the year, Ben earned a total of $2,080 in interest. Nice. Way to go, Ben. Write and solve a system of equations to find out how much money Ben invested in each account. Read the problem. How do you calculate interest? Interest equals the amount invested times the interest rate, but be sure that interest rate is a decimal. This is just a bucket of money plus another bucket of money. So let's get some buckets of money. We have 7% interest bucket and 9% interest bucket. If X is the amount of money invested at 7%, then Y is going to be the amount of money invested at 9%. So let's call that bucket X. Let's call that bucket Y. Here's my equations for this one. I know that bucket X plus bucket Y, it's got to equal 25,000. I also know that 7% times the amount in X plus 9% times the amount in Y is going to equal that amount of interest, which is $2,080. So I stare at these two equations and I go, what am I going to do? I think I'll use substitution. I'm going to subtract y from both sides of that top one so that I get 25,000 minus y is equal to x. And I'm going to take that and substitute it in there for x. This would give me 0.07 times 25,000 minus y plus the 0.09 times y equals 2,080. Now, I'm going to distribute that 0.07, multiplying it times the 25,000, and I'll get 1750 minus 0.07y plus 0.09y equals 2080. I'm going to combine those two like terms, that minus 0.07y and the plus 0.09y. I'll get the 0.02y. Then I'll subtract 1750 from both sides. Crunch those numbers. 2080 minus 1750. Got to get what that equals. When I do that subtraction, I get 330. And then I'll divide both sides by the 0.02, and I'll get that y equals $16,500. All right, that's an answer. That's the amount of money in bucket Y. I need the amount of money in bucket X. So X plus the 16,500 equals 25,000. Subtract 16,500 from both sides. You'll get that X is 8,500. Does this make sense? If I add these two, do I get 25,000? Does that make sense that if I multiply those each by their respective interest rates, that I would get that $2,080? It does. This one is complete. Let's do one of these money problems. Now, a school fundraising event sold a total of 253 tickets and generated a total revenue of $3,236.20. Now, each adult ticket costs $14.50, and each child ticket costs $7.95. Now, we're going to write and solve a system of equations, solve the problem. Read the problem. How do you calculate revenue? Revenue is the number of tickets sold times the price of the ticket. It's just a bucket of ticket money plus a bucket of ticket money. So there's my buckets of money. Those are at $14.50 each. These are at $7.95 each. Let's let X be the number of adult tickets sold and Y is the number of child tickets sold. So X and Y each go on their buckets. Here's my equations for this one. X plus Y is 253. Total number of tickets sold. Then $14.50 times each adult ticket plus $7.95 times each child ticket equals $3,236.20. How am I going to solve this? I think I'll do like I did before, use the substitution method. I'll take that top equation, subtract y from both sides. Then I will take what x equals, substitute it in there for x. This looks like the other one, doesn't it? That's 1450 times the quantity 253 minus y. Then plus 795 times y equals 3236.20. I'm going to distribute that 1450. Then I'll combine like terms. Then I'll have $3,668.50 minus 6.55 times y equals 3236.2. I'm going to subtract 3668.5 from both sides. And then I'll compute that number and divide by negative 6.55. I'll get that y is 66. That's an answer. That's the number of child's tickets. I know that x plus 66 equals 253. Subtract 66 from both sides. X is 187. That's the number of adult tickets sold. That's an answer. Does this make sense? If I add those together, will I get 253? Does this make sense? Yeah, it does. All right, we're going to look at some speed problems next. All right, let's see what our problem is. Looks like we got a ship going on here. We have a boat. He's traveling from town A to town B. He has to travel 2,542 miles along a river. Whew! The boat traveled from A to B along the river's current with its engine running at full speed. So he's going with the current there. This trip took 45.7 hours. Then the boat traveled back from B to A again with the engine running at full speed. But this time the current, it was against the river's current. So they're just trying to get that engine speed out of it. They're saying it's all the same. They had the throttle full on both times. Now this trip took 74 hours. The boat speed in still water with the engine running at full speed is. So its actual speed there of the motor, the river's current speed was blank. Right to solve. Oh my goodness. So let's read the problem. What are our speed distance equations? Well, the actual speed equals the distance over the time. All right, that speed equals distance over time. Now, you know, there's two different trips being made here, two different scenarios. We're going to have to break this down into trip 1 with the current and trip 2 against the current. You can't do this as one chunk of a problem. So let's let x be the boat's motor speed. The reason I said that is that's what they were asking for in the problem, so I'll let that be x. It's kind of a clue there. And they also want the river's current speed, so I thought, okay, why not? Let's let that be y. I don't know what else to do. But usually if you'll let the variables be the unknowns, the things that they're asking for, it'll help. So this is going to be trip 1, that's going with the current. There's trip 2, that's going against the current. So for trip 1, it's going to be the boat's motor speed plus the current. For trip 2, that speed is going to be the boat's motor speed minus the river's current. So, breaking it down into trip 1 and trip 2. Trip 1, the time for trip 1 was 45.7 hours. The distance was the same for both of them, but I'm still going to write it down, was 2,542 miles. We know that the speed is going to be the distance of that first trip divided by the time of that first trip. Well, I know what S1 is. It's x plus y. So I'm going to say that x plus y is the 2,542 divided by the 45.7. Let's look at trip 2. Time 2, that second trip took 74 hours. Yikes. Same distance. Speed, equation is still the same, but then the speed in trip 2 was x minus y. So I'm going to write x minus y equals 2,042 divided by 74. Those are perfect. Now I just have x's and y's. I'm going to go ahead and divide those numbers and tell you that x plus y is when I divided 2,042 divided by 45.7. I got 55.62. I did the same thing for the second one and found that x minus y is 34.35. Hey, I'm going to add these two equations. Look at how sweet that is. Add that up, you get 2x equals 89.97, basically 90. In other words, x is 45. What the heck was x? Oh, it was the boat's motor speed. Boat was going 45 miles an hour. Nice. If I want to get what the river's current speed was, take one of those two equations. I like the top one. 45 plus y equals 55.62. The river's current speed, 10.62 miles per hour. These numbers make sense. I'm happy. And there you have it. If you need any help with these, be sure to send me an email, rweaver10@alaska.edu. Have a fabulous day.